Hello everyone, hope all of you are doing good. In today's question, we'll try to deal with some of the applications of complex numbers. So let us take a question here. Let's say if a complex number is represented as z equals to 1 plus I divided by 1 minus I, then find z to the power 20. Okay. In this question, we'll try to cover two kinds of core concepts. One is complex conjugate, and the other is rationalization. So here, complex conjugate basically represents the other you can call it as the other complement of a particular complex number. Say for example, if z is represented as a plus ib, then its complex conjugate is represented as a minus ib. If you take a product of its complex conjugate with its exact other number, you get the real valuation around it, which is a square minus b square, as you can see. Okay, so these are some of the areas, some of the points that we will remember when we'll apply to this question. Similarly, rationalization means that if you have a complex number which is represented in the form of, let's say, two other complex numbers, 1 z2. So the attempt is always made to make the denominator real in order to solve for the actual value of that complex number. So how do we generally do that? We do it by multiplying the complex number with its complex conjugate on both the sides, both denominator and numerator. So that sort of makes the denominator real and helps us to divide the value across the numerator accordingly to give a representation in the form of another uh, complex number, where here x is nothing but your, okay, so the real value of this one divided by z2 of z2 one plus the imaginary value of z1 z2 over z2 of its and its complex conjugate, the product of its complex conjugate. So these two things will try to apply to this question here. So coming back to the question, it says z equals to 1 plus I divided by 1 minus I. So let's try to solve this. Here we'll try to use rationalization. So 1 minus I. Let's put some braces to make it more readable. Okay, plus I. So before we expand and we get the product, let's just remember the normal notations, that 1 I raised to the power 1 is I, okay, which is nothing but root minus 1. As we all know, I to the power 2 or I square is equal to minus 1. You can always deduce it using this notation. Similarly, coming to I to the power 3 will be minus I, and then I to the power 4 is equal to 1. Okay, let's remember this when we apply it here. So if you expand this, this will be, obviously this is of the form a square minus b square, so it is 1 minus I square, and if you expand this, this will be 1 plus I plus I plus I square. Okay, so if you go further down, it will be I minus I plus 2I minus 1, and this is 1 I square is minus 1, minus of minus remains plus, so it becomes 2. This cancels out, so we are remaining with 2I divided by 2, which is nothing but I, which means z is equal to I. So we have pretty much simplified this value, and we will try to now find out the actual question, that is, what is the value of z to the power 20. So z to the power 20 implies I to the power 20. 20 can be further broken into this format. We already know what is I to the power 4. It is equal to 1. So here 1 to the power 5, which makes it 1. Hence, that's the answer. Thank you for watching.